Okay, let's take a look at least common multiples, and we're going to be using prime factorization. So let's start with the one that has three numbers. So we want to find the least common multiple of the numbers 6, 8, and my cat's in the way, 10. So what we're going to do to find the least common multiple, we're going to take each of those numbers and tear them apart and see what they're made of. So I'm just going to go ahead and get those for the prime factorization of 6, 2 times 3, 8 would be 2 times 2 times 2, and 10 would be 2 times 5. I'm going to also put these answers, these prime factorizations, written with exponents, and you can decide which one makes it easier for you to see how this works. So we're going to take a look at it in two different ways. So the LCM, as we said, has to contain 6, 8, and 10. So if it has to contain 6, it's going to have to contain 2 times 3, and now we see that that's there. If it's to contain 8, we need to see 3 2's. Well, we already have 1, so this is an important point. You can reuse them. So I go, we already have 1, so let's squeeze another 2 in here. So I only added 2 more, and that, with this other one that was already there, that gives me the 3, so we see 8 there. Now, in order to see 10, we need to see a 2 and a 5. Well, we've got plenty of 2's there, but we don't have to have a 5, so we include that. And when you multiply all of that out, you would get 120. Okay, so let's try it a different way using the form of least common prime factorization using exponents. So everybody agree we see a 2. So what's the highest exponent of 2 we see? Well, there's a 2 cubed, and there's a 2. So we need a 2 cubed to see all of those. We need a 3, and we need a 5. So in either way, we would get 120. Okay, next example. Let's just try with 2 numbers this time. And the 2 numbers, let's make 50 and 75. And again, I'm going to do it 2 different ways for this problem, and then you can decide which way makes most sense to you and is easiest for you. So we know what we have to do. We take, let's just do it right here. We're going to tear those numbers apart. For 50, if we did it out using a factor tree, we would get 2 times 5 times 5. 75 would give us 3 times 5 times 5. So our LCM has to contain everything that we see there. It has, well, I shouldn't say that, it has to contain the 50, so I can write that down. We need a 2 times 5 times 5. It's there. But it also has to contain 75, so it has to contain 3 times 5 times 5. Well, do you notice we can reuse these 2 5's? They're already there, so we don't have to write them again, but we do need to get another 3. And I'm going to point out, let's see if I can do this with colors here. Here's 50, and here is 75. So we reuse those 2 5's. So what do we get when we multiply all of that out? We would get 150. Okay, let's keep going, and I'm going to check my time. So let's see. Let's try the numbers 10, 15, and let's make it 25. So again, you know what to do. List those numbers, tear them apart to see what they're made of. 2 times 5, 3 times 5, 5 times 5. Okay, and this one I'm going to do 2 different ways. 10 equals 2 times 5, no exponents there. 15, 3 times 5, and 25 is 5 squared. So I'm going to do it both ways. The LCM, using this first method, we've got to see a 10, so I'm just going to write that down. And we know you're there. We go to the next one, 15. Well, we need to see a 3 and a 5 being multiplied. We already have a 5, so we can just add the 3. So do you see 3 times 5. Yep, there it is. 5 times 3, same thing. So it's there. And then finally, to get 25 involved, we need to see 2 5s being multiplied. Well, down here we've got 1 5, but we need 2. So I'm going to continue and get another one. And when we multiply that out, we would get 150. And let's look at just one more way. We see a 2, there it is. We see a 3, there it is. We see some 5s, 5, 5, and 5 squared. The biggest one we see is 5 squared, but again, we would get 150. Okay, let's do one easy one to finish off. 9 and 12, 3 times 3, 2 times 2 times 3. What do you think the LCM is going to be? To see 9, we need that. To see 12, we need to see 2 2s. I don't see any down here, so I'm going to include them. We need to see a 3. Well, I already do, so we don't have to give that twice. So we would get 36 is the LCM. And again, what that means is 36 is the least, in other words, the smallest, common, meaning both 9 and 12 go into 36. So there we go. I think that's good for that, and I think we're then going on to R3. Okay, we'll see you there.